Welcome at the website of the WIDES database for disinfectants. My name is Manfred Klade. In cooperation with a team of experts, I developed the assessment scheme of the WIDES database. Within the following minutes, I'm going to present you some of the basic principles and rules of the assessment procedure in the WIDES database. At the beginning, I would like to discuss the motive, framework, conditions, and limits of the WIDES assessment. Undoubtedly, the use of disinfectants in hygienic risk areas is necessary to combat microorganisms and viruses, especially in times of a pandemic. Disinfectants protect health, but with frequent use, they themselves have properties that are hazardous to health and the environment. With frequent contact, biological active ingredients can damage the skin, trigger allergies, damage aquatic organisms, or accumulate in the aquatic environment. The purpose of the WIDES is the collection, assessment, and comparative presentation of substance information. It makes the hazard potential of different disinfectants in identical application situations comparable at a glance. This makes it easier for you to identify the least hazardous among the sufficiently effective products on the market and to avoid health and ecological damage of an application in the best possible way. WIDES thus offers you support in order to meet the legal requirements for environmental and employee protection and to document this in a comprehensible manner for yourself and others. For a better understanding, a note. The WIDES assessment does not contain any statement about the probability of occurrence of risks, but about the fundamental hazard of products. The consumption of resources in the production and transport of disinfectants is not integrated into the ecological assessment, but only the hazard potentials in their disposal via the wastewater. The WIDES database is committed to the precautionary principle and is comparable to occupational health and safety models as a tool for the substitution of problematic products. Now to the individual elements of the WIDES assessment. In the first step, we categorized the dangerous properties of disinfectants for human health and our aquatic environment. In the second step, the ingredients of disinfectants in these 6 categories were assessed. Finally, the products were assessed considering the substance assessment using our calculation model. Thereby, respective concentrations of the ingredients in the application solution were taken into account. In the first part of my presentation, I will cover the substance assessment. I will start with our concept of hazard categories, of assessment numbers, and present the assessment scheme. Since the database is crucial for substance assessment, I will go into the origin of the data. And I'm going to explain how we deal with data gaps and data uncertainties and why we don't indicate data gaps for surfactants. Then I will introduce the ABC categorization, which facilitates the rapid identification of hazardous ingredients. And finally, I will illustrate the substance assessment using the example of the biocidal active substance glutaraldehyde. Here you can see an overview of our hazard categories. 4 categories describe adverse impacts to human health, namely acute toxicity, especially for the respiratory tract, irritation and corrosivity, sensitization and allergenic potential, and the hazard category mutagenic, carcinogenic, toxic to reproduction, the so-called CMR properties, as well as the chronic toxicity. Disinfectants can enter surface water via the wastewater and the sewage treatment plant. Adverse effects on aquatic organisms or a lacking or poor degradability are covered by the hazard categories behavior in surface waters, acute and chronic. Finally, the category flammability assesses the fire hazard arising with the application of flammable, predominantly alcoholic products. In the substance assessment, the extent of a hazard is described by integer assessment numbers and a color code. I will show how a hazard potential is assigned to an assessment number in the next slide. Here I want to mention that assessment number 1 excludes a hazard on a sufficient data basis. Assessment number 2 indicates a low, 3 a medium, 4 a high, and 5 a very high hazard. Assessment numbers from 6 upwards indicate an extremely high hazard. Data gaps or data insecurities are indicated by a question mark. If a substance defined in the WIDES as surfactant is not assessed in a hazard category, this is indicated by NB for not assessed. I will go into the reasons for this later. The WIDES assessment scheme mainly relies on hazard statements. Hazard statements consist of the letter H and a 3-digit number. They are used for labeling and classification of the hazardous properties of substances and preparations. Hazard statements are used worldwide in accordance with the Globally Harmonized Classification and Labeling System, or GHS system for short. In the EU, it is implemented with the CLP regulation. The table shows how hazard statements in a specific hazard category are assigned to assessment numbers. Due to the scope, I only explain here, for example, the assessment numbers for the category acute toxicity. If substance data exclude a classification, we assign assessment number 1. Classification as harmful to health causes assessment number 3. Classification as toxic, assessment number 4. If the substance is classified as toxic and at the same time is corrosive, we assign assessment number 5. A substance receives the high assessment number 6 if its acute toxic effect is associated with danger to life. For further explanation, I refer to the PDF document Introduction to the Assessment Framework on the homepage of the WIDES. Since the hazard statements play such an important role in the assessment of substances, I want to mention the origin of the classification forming the basis of the WIDES assessment. WIDES prefers classifications drawn up or audited by an independent authority. These may include, for example, classifications drawn up under the EU Biocidal Products Regulation. Such independent sources are currently only partially available. For this reason, the WIDES mainly uses classification from the manufacturer's REACH registration dossiers. The table shows the status for April 2021. If a data gap or data uncertainty occur during the assessment of a substance, the WIDES assessment indicates this by a question mark. Data gap means there are no data available to assess the substance in the hazard category. If a question mark is attached to the assessment number, the assessment made is uncertain considering the available data. The screenshot shows a substance assessment in 6 hazard categories with a data gap and data uncertainty in 3 hazard categories. The assessment of surfactants differs from that of other ingredients in the following point. Data gaps in the hazard categories sensitization, allergenic potential, mutagenic, carcinogenic, toxic to reproduction, chronically toxic, and behavior in surface waters, acute and/or chronic, are not indicated with a question mark, but are reported as not assessed with NB. This ensures that question marks are only used as an indicator of a data gap for substance groups of high concern, especially for biocidal active substances. I now refer to our ABC categorization of ingredients. To facilitate the selection of safer disinfectants, we distinguish between substances of lower and higher concern. Based on classifications and/or data gaps, a substance is assigned to category A, B, or C, respectively to the colors red, yellow, or white. Category A covers substances which pose even in low concentrations high and/or irreversible hazards to human health and the aquatic environment. This category includes substances that are mutagenic, carcinogenic, toxic to reproduction, chronically toxic, allergenic, and highly toxic to the aquatic life. Substances which are suspected of damaging the unborn child or may cause harm to breastfed children also fall into this category, considering the precautionary principle. Disinfectants with category A substances should be considered for substitution. Category B covers hazards with significant adverse effects on human health and the aquatic environment. High acute toxic hazards such as fatal or toxic if swallowed, in contact with skin or inhaled, are assigned to category B. Their effect is dependent on concentration and decreases significantly with the usual dilution. Likewise, substances which are suspected to be mutagenic, carcinogenic, affecting fertility, or chronically toxic are assigned to this category. Substances with a significant hazard potential for the aquatic environment and substances for which certain hazards cannot be excluded due to data gaps and data uncertainties are assigned to category B. Category C, marked with white color, covers limited, controllable, and/or reversible hazards. We assign corrosive properties expressed by the hazard statements H314 and H318 to this category. We assume that corrosive properties decrease with dilution and can be controlled by appropriate safety measures. Although hazards associated with category C are not insignificant, such substances should be preferred. This applies especially to biocidal active substances of category C, such as some oxygen releases or organic acids. This and the next slides show the assessment of glutaraldehyde in all 6 hazard categories. On the left you can see the assessment numbers with the color codes, and on the right the assessment relevant data, as well as their source. Glutaraldehyde is classified with a hazard statement H330, fatal if inhaled, causing assessment number 6 in the hazard category acute toxicity. Since glutaraldehyde is classified with hazard statement 1B H314, this classification leads to assessment number 4 in the hazard category irritation and corrosivity. Glutaraldehyde is further classified with hazard statement H334, may cause allergy or asthma symptoms or breathing difficulties if inhaled. This leads to assessment number 5 in the hazard category, sensitization allergenic potential. The source of the classification is an assessment report prepared for the EU Biocidal Products Regulation. Here you can see the assessment of glutaraldehyde in the hazard category mutagenic, carcinogenic, toxic to reproduction, and chronically toxic as a result of 4 partial assessments. The total assessment number results from the highest partial assessment number. The partial assessment for mutagenic gives assessment number 1, for carcinogenic assessment number 1, for toxic to reproduction assessment number 1, and for chronically toxic assessment number 1. This means a hazard is excluded in all partial assessments based on the data available, and thus glutaraldehyde is assessed with 1 in the overall hazard category. As far as the hazard for the aquatic environment is concerned, glutaraldehyde is classified with hazard statement H400 and multiplication factor 1, very toxic to aquatic life, and hazard statement 411, toxic to aquatic life with long-lasting effects. These classifications require the assessment number 3, both in the hazard category behavior in surface waters acute and chronic. In the second part of my presentation, I explain the calculation model for product assessment based on ready-to-use products and concentrates. I will work out the advantages of the calculation model we have chosen. Then I will explain our exposure model and how we assess the fire hazard of products with the hazard category flammability. Finally, I will discuss the validity and limitations of product comparisons. Now I would like to outline how a product is assessed. First, the substance assessment number is logarithmically scaled with the formula 10 high assessment number and multiplied by the substance concentration. This is done for each substance contained in the product. Then in each hazard category, all numerical values are summed up. The sum is delogarithmized to give the assessment number of the product. And finally, the product assessment numbers are transformed into a color code from light yellow to red. I first explain the calculation model for ready-to-use products in the hazard category sensitization allergenic potential. Ready-to-use products include skin and hand disinfectants, alcoholic and aqueous products for rapid disinfection, and products for hygienic hand washing. The example shows an aqueous disinfectant containing ingredient A and B. A is classified as respiratory sensitizing with hazard statement H334 and assessment number 5. The logarithmic scaling with the formula 10 high assessment number leads to the hazard factor 100,000. B is not classified but indicated to be a very weak contact allergen in a database for occupational health. It receives assessment number 2. Unrated substance content means the solvent water and any other ingredient without a hazard statement and therefore not mentioned with classification in the safety data sheet. Approximately, we assume that this product share does not cause any hazards and therefore assign assessment number 1, no hazard, and hazard factor 10. The hazard factors are multiplied by the respective substance fraction. This is the concentration divided by 100. Finally, all shares are summed up and the sum is delogarithmized. In this example, the product assessment number of the disinfectant in the hazard category sensitization allergenic potential is 2.0. Next, I explain the calculation model for concentrates in hazard category sensitization allergenic potential. Concentrates are diluted before use. Products for instrument, laundry, dishes, and wiping surface disinfection are mostly concentrates. The calculation example shows an aqueous disinfectant with ingredient A and B. A is classified as respiratory sensitizing with hazard statement H334 and receives assessment number 5. 5 results in the hazard factor 100,000 with the formula 10 high assessment number. B is not classified but indicated to be a very weak contact allergen in a database for occupational health. It receives assessment number 2. After logarithmic scaling and multiplication with the respective substance fraction, this is the concentration divided by 100. The results of the two ingredients as well as for the unrated substance content are summed up. The result is 10,018. Since the concentrate must be diluted to a 0.5% solution for use, the assessment is supplemented by a dilution calculation. The hazard factor 10,018 is therefore multiplied by the substance fraction 0.005. In the calculation, the dilution medium water receives the assessment number 0 for two reasons. Firstly, a hazard can be completely excluded in the case of pure water, and secondly, negative assessment numbers are thus avoided. The assessment number of the diluted application solution is 1.7. I now explain the reasons why we logarithmically scale the substance assessment number in the product assessment. To illustrate this, I start with the classification of a preparation according to the CLP regulation. The product may contain an ingredient classified as respiratory sensitizing H334. At first glance, it would be obvious to use such a classification for product comparisons, especially as they are given in the safety datasheet. Therefore, this and the next slide explain why such classifications are not useful for comparative assessment of disinfectants as application solution. According to the CLP classification rules, a concentration equal or above 1% requires the product to be classified as H334. If, on the other hand, the concentration is less than 1%, the sensitizing substance is not visible, respectively has no impact on the product classification. In this slide you can see the effect of logarithmic scaling, especially at low concentrations. Logarithmic scaling ensures that the sensitizing substance posing a high hazard is considered appropriately even in low concentrations. Since the logarithmic scaling smooths the assessment over the entire concentration range and avoids jumps, product comparisons remain significant even at small concentrations and with little differences in concentration. Logarithmic scaling is important when assessing substances with allergenic or CMR properties. This slide shows the effects of various low concentrations of the respiratory sensitizing ingredient A on the product assessment number and the color code. Concentrates with dilution and ready-to-use products differ in the best possible product assessment number, respectively color code. The reason for the difference is that in this way, in the dilution calculation of concentrates, negative assessment numbers are avoided. This difference is irrelevant since there is no possibility in the WIDES to directly compare ready-to-use products with diluted concentrates. So only products are compared which are assessed according to the completely identical calculation mode. In addition, the generally darker shade for ready-to-use products indicates that concentrates perform better in terms of resource consumption and transport and should be used preferentially. The WIDES assessment considers exposure with a simple model of correction factors derived from vapor pressure. Correction factor F Hume considers that volatile substances can partially escape into the room air. Since they can be inhaled at the site of use, the factor weights volatile substances more strongly in the hazard category acute toxicity. Correction factor F eco considers that low volatile substances can enter the surface waters via the sewage treatment plant. The factor therefore weights low volatile substances more strongly in the two hazard categories, behavior in surface waters, acute and chronic. The following example shows how correction factor F eco weights assessment in hazard category behavior in surface waters chronic. For this purpose, two concentrates with ingredient A, respectively B, are compared with each other. To emphasize the effect of the exposure model, the hazard potential, content, and dilution of ingredients in product 1 and 2 are identical. However, ingredient A has a low vapor pressure, ingredient B a high vapor pressure. A is therefore more likely to enter surface waters than B. The integration of F eco into the product assessment results in a less favorable assessment for product 1 with a low volatile ingredient A, assessment number 1.9 in terms of aquatic toxicity than for product 2 with a high volatile ingredient B, assessment number 1.4. The difference is expressed in the different color code. The hazard category flammability is only applied to products classified as flammable. In the present case, this is caused by significant concentrations of alcohol. The assessment number for flammability consists of a basic assessment number derived from the product classification and supplemented by surcharges or discounts. The latter depend on the ignition temperature class, the lower explosion limit, the explosion range and the flash point of the product. When products are compared, the following must be considered. The product assessment numbers are transformed into respectively displayed as a color code. This is due to the following reason. The calculation is based on simplistic assumptions which can be visualized more adequately by a color code than by an exact numerical value. To ensure fair product comparisons, the WIDES does not allow comparisons between ready-to-use products and diluted concentrates. This is guaranteed by a query requiring information on the field of application, the exposure time, and the spectrum of activity. After the query has been carried out, WIDES does not provide a product ranking. Assessed products are ranked alphabetically, but rankings can be generated within each category with a single mouse click. With this, I have explained to you the essential elements of the substance and product assessment in the WIDES database. For more detailed information, I would like to refer to the PDF document Introduction to the Assessment Framework, downloadable from the WIDES webpage. I hope that my explanations were helpful. You may contact me at the email address given.